Hey, Carl. Thanks so much for the question. This is a pretty tricky one, but hopefully I can help you out with it. There's a lot going on, but it comes back to combinatorics, understanding permutations. Um, and I think that the best place to start is probably drawing a little diagram with this. And I think this is a topic that I definitely struggled with as well when I was going through school, just because a lot of it feels like it's the same problem, but uses then different numbers, different formulas. So I've really found that drawing little diagrams, as labor intensive as they might be, are really helpful. So 2 things here. This represents the 6 different spots we have to fill to make a hex code. And these are our 16 different options. And I think it's important to lay these out because the options we have are not equal in size. We've only got letters A to F, but we've got all other numbers in terms of single digit. And so that's going to be interesting when we look to calculate our different permutations here. It's going to be interesting to consider, okay, what's the ratio of letters to numbers? And yeah, you can confirm that this matches up with your 16 to the power of 6, because you've got 6 here, and you should have another 10 here, if you include 0. 0 is important to include there. Okay, the next part of it is like, okay, we want to define what the question's actually asking us. So we need 2 identical letters grouped together with no other repetition of this letter. So we've got 3 distinct conditions here. First of all, 2 distinct letters. So we've got 6 possible choices there. We can have AA, BB, CC, DD, EE, FF. Cool. So that's what I've written here. 6 different letters. With then our group together consideration, what that means is that they've got to be side by side. So you can't have like A here and A here. Like that doesn't count. And so there's only actually 5 ways that we can do this. It can be these 2 boxes, these 2, etc., etc. There's 5 ways, and I've shown them here. And so from that, we can first derive, okay, what's the number of ways of doing this part if there were only 2 boxes, for example. So there's 6 letters and 5 different ways that we can arrange them in groups of 2. That'll give us 30 possible ways in which we can get our grouped letters there without worrying about what we're doing with the other 4 yet. So, and you can manually verify this. It would just be A, B, 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 etc. Right? Okay, but we're not done yet because we have to ensure that there's no other repetition of this letter. And how we do that is we go, okay, we've solved 2 of them, essentially. That one's done. I'll do it in a different color. This one we're good. This one we're good. Now we've got to make sure the other 4 have no repetitions. Mathematically, how we do that is we need to consider, okay, if A was the value we used, right? For these remaining 4 positions, we've only now got 15 candidates. We've gotten rid of 1. And so what we've done here is said, okay, well, there's now only 16 minus 1 options, 15. Only 15 options. And we want to find, okay, from our 15 options, how many unique ways can we actually fill these remaining positions? Because if we have A, it'd be different than if we have 1, 1, 1, 1 versus 1, 1, 1, 2 versus 1, 1, 2, 2. So even though this block of 2 is staying the same, there's going to be lots more iterations on that, and that's what makes this problem tricky. Okay, so we've got 5 different candidates. We've got 4 different spaces. We can do this quickly, but we need to determine, okay, is this going to be a combination or a permutation? And the key test I like to use here is, okay, if we take like 3 of the possible options, so let's go A, B, and C, right? If I draw A, B, and then C, is that different to drawing B, A, and then C? If we're talking about a scenario where it's like, hey, I just want to choose 3 people, doesn't matter the order, then that's a combination. The order doesn't matter here. But if ABC and BAC are distinct arrangements, which they are here, what you'll get is a permutation. Cool. And so once we've defined that, we can say that, okay, we want to find the possible permutations of these 4 spaces. That's going to be 15P4. And obviously this is a calculator problem. So I'm going to put that in my calculator, and that gets us a big number, 32,760. All right. So that's how many ways we can arrange this group we know that there's 30 ways of arranging this group. So then the total number of ways that we can arrange two identical letters grouped together with no repetition of this letter is going to be 30 multiplied by 32,760, which is let me just put it in my calculator quickly. 30 times 32760. Okay, that gets us 982,800. All right, so this is our number of ways now. But importantly, we're not finished quite yet, because what our question asks for here is not a number of ways, but an actual percentage of the total hex code combinations. We know there's 16 to the power of 6 different codes. So the probability of getting identical group, no repeat, would be 982,800 divided by 16 to the power of 6, which is 0.05857. But more specifically, as a percentage, it's going to be times 100. So that will be about 5.9 to 1 decimal place %. And so in summary, we've got 6 places we need to fill with 2 individual conditions which have kind of sub-conditions in there. So first condition was that we need to group 2 letters together. There's 5 different ways of putting this in place within our 6 letters, or 6 letters or numbers, I should say. 6 different letters, 30 ways to do that. We've then got to figure out, okay, how can we arrange the remaining 4 places in terms of permutation format? And because we've got one that's now off the table, that's 15p4. We then multiply this together to find the total number of ways of doing this entire sequence. Divide it by the number of ways to find all hex codes times 100, that's percentage. I'd be really interested to know, obviously I don't have the answers for this, so this would be my best guess and my approach to how to do this, particularly in light of, look, we're going to try and use permutations, like it's a combinatorics unit. So this would be my best guess. I feel like that's a reasonable number, but I'd be really interested to know in the comments or elsewhere if you've got a solution to this, what it is and what it does, because I'm happy to look deeper into this if that isn't the answer you're after. All right, really appreciate the question. If you found it helpful, I'd love it if you could subscribe, maybe even like the video, but hope that's helpful, and yeah, tricky one. Thanks very much.